Hello everyone, welcome back. So continuing with the linked list series, our next problem is called remove nth node from the end of the linked list. So basically, we will be given a head of the linked list, a singly linked list, and we will be given a number, integer number n, and we have to delete the nth node from the last. Like for this given example, for 1, 2, 3, 4, 5, and n is given 2, the second last node over here is 4. Like 5 is the first last node and the 4 is the second last node. So we have to remove this 4 and return the head of the new linked list. After removing the second node from the end, the linked list now will become like 1, 2, 3, and 5. So we have to return this one, the reference to or the head to the linked list. So note the n will always be valid, so we don't have to like check for invalid n's. And the follow-up question over here is, can you do it in single pass? So this question is not that tough if you just think of it like in simple way, but this is coined as a medium problem just because of this follow-up question. Like if let's say the interviewer asks you to do it in only one pass, like only traversing the whole linked list only once. So how to do it that way? Let's look into it. So let's go to the whiteboard and let's see how to do it. This is the example given over the LeetCode. Like we have 5 nodes called 1, 2, 3, 4, and 5, and the n over here is given 2. So the second last node is 1, 2. It is 4, so we have to remove 4. So now let's first think of it like how to do it in a naive way without thinking about the follow-up question like in single pass. So the naive way of doing it will be like we can count the total length of the linked list using one pass of the linked list. Like using one traversal, we can find out that the length of this linked list is 1, 2, 3, 4, 5. So if we count the length, it will be 5. Now if we know the length is 5, we can easily find out that the second last node will be occurring after the count will be 3. Like if we do 5 minus 2, we will get 3. So the second last node will be, if we starting from the beginning, it will be 1, 2, 3, and after 3 it will be the second last node. Okay, so in this way we can do it. But for deleting a node from linked list, we know that if we have this pointer, we cannot like go to the previous pointer because it's a singly linked list, right? So that's why we have to get the pointer or the reference to this node, so that we can do what? We can make the next of this node to this, so that this node will be deleted. So we are doing what we are making next of 3 as 5, so 4 is deleted. So that's why what we have to do is we have to add a dummy node in front. Let's say the dummy node is -1. So in this case, whenever we are like doing 3 steps and next node like 1, 2, 3, or rather if we count this one, 1, 2, 3, and the next one, so we will be getting the reference of this. So what we have to simply do now, we have to make the next of this node as next of next. Like we have to move this pointer to here so that this node will be deleted. So this is the simple way of doing things. But the question here asks like, can you do it in single pass? So we have to do it in single pass. So how we can do it in single pass? So now let's look into that part. Okay, it is not that tough if you like have basic idea of pointer manipulation of linked list. For this case also we will need this dummy node at the in front, because for all the cases we have to like come to the n minus 1th node, so that we can make the n minus 1th nodes next to n minus 1th nodes next. So that's why we have to come over here if our nth node from last is this one, because we have to make the next of this node as this node, so that this will be deleted. So now what we will do is we will take two pointer. One pointer is slow, one pointer is fast. So these both pointers will be pointing to this dummy node, So in this dummy node, let's just call it dummy. It is dummy node. So this is a slow pointer and this is a fast pointer. So now what we will do is we will increment this first pointer n plus 1th time, So here n is 2, so after incrementing n plus 1, so we will be incrementing it 3 times. Like from here, if we increment it 3 times, where will it reach? 1 2 3, so it will reach over here, and the slow pointer will still point to the dummy node. Okay, the slow pointer will point to the dummy node, so it is the first pointer. So what is the basic need of this? We want to maintain the distance between slow and fast pointer as n. So that's why here we can see it is having exactly n nodes in between them. So that's why we incremented the first pointer n plus 1 at time. So now after doing this, if we increment the first pointer by one value, so let's say first will be here and slow will be here, after that again fast will be incremented and fast will be here, slow will be here, and after that slow will point to over here, and the fast will point to null, because here it is null, end of the linked list. Whenever we hit null at the first node, we know this node is n minus 1th node from the end. So we just have to do what? We just have to make slow dot next equals to slow dot next into dot next. So basically what this line will be doing is, this line will be making the slow pointer's next node pointing to its next dot next. So here, so this node will be deleted from the linked list, and whenever we have to return the answer, we will do what? We will return dummy dot next, because this is our head, right? Dummy dot next. So this is our head. So the new linked list will now look like 1 2 3 and 5. 4 is deleted. So this is our algorithm, and this will do only one single traversal of this linked list. So that's why the time complexity will be O of n, and that is also single pass, and this is time complexity, and space complexity will be constant because we are not using anything else. So this is our algorithm. Now go to the code editor and let's code it. So now writing code for this problem will be pretty straightforward. So we will do what? We will first initialize a dummy node. So let's call it dummy, and we will make it list node, and we will put a value like -1. And after that we will make what? Dummy dot next pointing to head. So now for our case, the dummy becomes the first node of the linked list, and we will having two pointer called slow and fast. Both will be pointing to dummy. So both will point to dummy. Now what we will do is we will run a loop until n plus 1 is not 0, and we will increment the first pointer as first dot next. We will be incrementing the first pointer as first dot next and decrementing the count of n as usual. So after that, the first pointer will be now pointing to in the difference from, and after this loop what will happen is the difference between the fast and slow pointer will be n, like exactly n number of elements will be between them. So after this what we will do is we will do another loop. Or don't get confused, like we are running two while loop, that doesn't mean that we are doing two passes, because we are traversing the whole list only once. Like we incremented the first up till the difference between the fast and slow is n, and then again we increment the slow and fast again until the fast reaches the end. So we are doing only one pass here. So in this loop we will do until fast is not null, we will increment both slow is equal to slow dot next and fast is equal to fast dot next. So after that slow now must point to n minus 1, sorry, n plus 1th node from the end. Like if let's say in this case nth node from last is 4, so now the slow will point to 3. So what we have to do now, simply make the next of slow equals to slow dot next. So that is exactly what we will do over here. Slow dot next is equal to slow dot next dot next, and after that we just simply have to return dummy dot next, because dummy is a node we added in the beginning, so the head will be dummy dot next. So let's run it, and it's accepted. Let's submit it. So here we can see it is getting accepted. So this, the time complexity I've already told, it is linear in time. So that is how we have to solve this question in a single pass, called nth node from end of the linked list. We have to remove that. So thank you for watching, hope you liked it.